Hi, we're here with Paul Kling from Schneider Electric Motion, and Paul is going to take us through a demonstration of hybrid motion technology. Paul, from what I see here, if I ever want to move a brick on a conveyor belt, I know where to go. What do we got here?
That's a good observation. So, whether it's a brick, whether it's really across any industry, what we're showing here is a unique capability. We're taking our integrated product, motor drive control, and we have a very unique control algorithm in here that in essence takes a stepper-based product and gives you the performance of what you would think of as a two-phase servo. And we're going to show you this on the demo. I'd like to take a minute and give you a quick demonstration of our integrated Lexi drive product, really focusing on what we call hybrid motion technology, or hMT, which gives a stepper system really a true closed-loop performance. So normally if we run a stepper unit and we exceed the load, the typical thing that happens is the stepper stalls. So I'm going to demonstrate that by dropping this inertial load on it. As you can see, the belt stopped. This stepper in open loop mode ended up stalling. What I'm going to now do is implement our hybrid motion technology. It's a proprietary control algorithm that really creates this variable torque, variable current capability within our stepper. With that algorithm active, I can take this very same load, drop it on the same inertial disturbance, and you'll see that you get no stalling. This is really unique in that you really take what is a stepper-based unit and turn it into the performance of a two-phase servo.
What kind of applications do you run into where that dramatic load change is a factor?
So applications really vary depending on the industry and the market. But if you look at all industries and marketplaces, they typically have some type of load variation or could have a load variation, even end of stop and safety applications. So this technology is not just from a pure motion side of it, but it's also to help address safety concerns so that you can actually have a controlled way to control the rotary or linear motion.
How much does the user get involved in implementing the algorithm that adjusts for that?
It's a great question. So because it's a fully programmable unit, the OEM can go in and actually set parameters. And so what this does is it gives you a very controlled way to adjust for disturbances. So they can control the torque and or the current in the motor, how it responds, and then how you actually want to recover from a disturbance of the load. And that is very unique compared to other motor technologies.
Can you keep track of the position of the system even when there's a load variation?
Absolutely. So that's a wonderful question, and many of our OEM customers ask the very same thing. Because we're in a lot of high precision applications, the end position of where that load is very critical. And so yes, we are actually keeping track of the position. If it slows down or speeds up, we know exactly where it is and exactly where it needs to be. So following that disturbance, they can program it as to how they want it to recover to make sure that if it's an end position that it needs to get to, they can program it to finish at that area, at that place.
Are there any limits to some of the physical factors involved, like acceleration or maximum load you can deal with?
So the way that hMT works is that with a stepper system, the important thing is to never let the rotor and the stator get out of phase. And so the way we control that is to be able to control how much out of phase that gets. And we do that by controlling the current, which ultimately controls the torque, and then we also control the speed. And so there really is an infinite number of control that they can adjust it to, but ultimately if the load exceeds the capability of the motor, you'll actually get to zero speed, full torque, but you'll never lose the controllability of the shaft of the motor.